Hi, my name is Kieran Milne. I'm a technical program manager and information developer with the information experience team here at Juniper Networks. This Learning Byte will cover route sharing using rib groups. So rib groups are used to import routes into or export routes out of a non-default routing table or rib. Now that immediately sounds a little bit complicated, but don't worry, we will be discussing that as we go along here. In terms of rib groups, we talk about importing and exporting a lot, and those terms are used in relation to the ribs themselves. So we would say routes are imported into a particular rib, or routes are exported out of a particular rib. For rib groups, you can apply import policy to filter what is shared between ribs, and rib groups also support IPv4 and IPv6 routes. So let's pause things here and just talk about that idea from the previous page, the idea of default versus non-default ribs or routing tables. So this is a simplified diagram here, and it's the way we usually think of routes flowing through a device. Routes come in on the left side there. They go into their related protocol rib. The rib runs some algorithms and determines which routes to install into the actual routing table, in this case, inet.0. To move things along, those same routes can be taken out of the inet.0 table in this case, run through the protocol rib again, maybe some export policy, and then sent downstream to other neighbors. And that's correct. That's a simplified way to look at it. But then something that's important to kind of add into the mix here for our conversation is the idea that as routes come in on the left side and they run through the protocol rib, they're being installed into the inet.0 table here in a way that we would say they are being imported into the inet.0 table. And likewise, they are being exported out of the inet.0 table to the protocol rib and sent downstream to neighbors. And that distinction is important for the following reason. The part we were looking at is the default or the master routing instance. I've now added a new routing instance, the test routing instance. And what's important to know here is that there's this concept of a default position for a given route and a non-default position for a given route. So using that same example again, an OSPF route or a route arrives on the left side at the master routing instance, goes into its related protocol rib, and it's installed into inet.0. That's the natural position for that route. It came in on the master routing instance, it worked with the protocol rib in the master routing instance, and it's installed in the table, the routing table in the master routing instance. So that equal statement is also applicable in the bottom half of this diagram. A route that might arrive through an interface that is associated with the test routing instance would be associated into the protocol rib in that routing instance and imported and installed into the test.inet.0 routing table, and so on. So it's important to keep in mind there's this default position that any given route should kind of naturally fits into in a Junos device. And anything that varies from that default position or placement is a non-default location for that route. So that's a concept that's important to understand as we go forward here. So going back to the rib groups themselves, there's this concept of import rib and export rib. So let's just run down the variations here. To start with, this is the default behavior. So a route arrives at the device like we were looking at on the previous slide, and it's installed into a routing table. Now, a rib group that's an import function can import a given route to a non-default routing table. So the route arrives at the device, and it can be redirected. So it doesn't go into its natural position in the routing table. It goes to a non-default or a non-native routing table. That's one of the import options for rib groups. Another import function for rib groups is that you can share the routes that are coming into the device to multiple tables. So there's maybe a natural position for the route. Maybe you want to share it with another routing table. So it's in two locations. So that can be an interesting way to do that. And in fact, that is the key to what we're going to be doing here in this Learning Byte. The last option here is the other side of the equation. It's the export function. And so when you're exporting a given route out of a device to neighbors, you can, using the export function, pull those routes from a non-native or a non-natural routing table. So those are the options for import and export in terms of rib groups, and again, sets the stage for what we're going to do here. That third option is the one, the route sharing option, and that's the one we'll focus on as we go forward. Let's look at rib group configuration. There are really two steps to rib group configuration. The first one here is to define the rib group itself and specify an action. So under the routing options stanza, and that's the global routing options stanza, that's the one you always use to create rib groups. You can define rib groups, rib group name, and then these options here don't need to all be here. Let's just walk through them. Some of them are required, some are not. So in terms of an import context, the import rib statement is what you want to use, and there are two elements, a source table and a destination table. This order is important, and we'll talk about that in another slide or two. But in short, the source table here identifies the natural default position for those routes that you want to share. And then similarly, the second element is the destination table or tables where you want to share those routes. There are a couple of other options here. Import policy is a mechanism to control what is shared between the given tables. So for example, you might use the import rib statement to share some routes between tables. Now you don't want to share all of the routes between those tables. You want to control or filter and narrow down what exactly you share. Well, you can use the import policy statement for that, and we'll see that in the demo. And lastly, another optional item is that export rib option. As you saw on the previous page and slide, it allows you to pull routes and export them from a non-default or a non-native routing table. And this allows you to do that using the export rib statement. And you simply identify that non-default table that you want to pull and export from. So all of that is the first step here, defining the rib group and specifying the particular action here of the options that are available. Second step is to direct these routes, direct the routes from wherever they've been arriving on your device, so what protocol and what have you, to define and direct those into the rib group up in step one. So there's a generic example here on the bottom. Under protocols, a given protocol, for example, OSPF looks a lot like this one. Might be protocols, OSPF. You simply specify the rib group statement and point those routes into the appropriate rib group that you defined above. Now, to be clear, these stanzas here in section 2 can vary quite a bit. This is, like I said, an example that matches OSPF. It also matches PIM. Interface routes are done a little bit differently. BGP is configured a little bit differently, so it can vary, but the concept here of step 2 remains the same regardless. A quick note on why the order matters here. On the previous slide, you saw that with that import rib statement, or that line, I mentioned the source table and the destination table or tables. Well, there's a reason that that's really important. And so as you start to bring some of these concepts here from the previous page together, this first example is the import rib statement, and it first defines the inet.0 table, and then the test.inet.0 table. And it does what you see on the diagram here. Routes are being received, or they are arriving on that master routing instance, going through the protocol rib, and here's where that import rib or that import mechanism becomes really important to understand. As you can see, we are first sharing it into our natural routing table, the source routing table, but we're also defining that destination or target routing table to share to. And in this case, it's the test.inet.0 table. So this first statement here, this first import rib statement, does what you see here. Now, the second import rib statement in the middle of the page is reversed. The tables are reversed. And that's really important because it changes literally what happens here. As you can see, in this case, the routes are actually receiving or being received on the bottom, the test routing instance, running through that protocol rib and being imported and shared and installed, as you can see there, into both routing tables. But again, that context is really important from the start. It helps to understand the default, the natural position of a given route, where its natural place is in these routing tables. And it helps you to understand what the source table is and the destination table is when we use this import rib statement. All right, that takes us on to the demo here. Let's just set up what we're going to be working with. So we have our Junos device, and we have on the left side the master routing instance, this is the default routing instance. And on the right side, we've configured a routing instance called test. You can see the related routing tables there. We're going to be using the related inet.0 tables. Each instance has an interface configured and an IP address assigned. And with that, we're going to do the following. The first thing is we're going to share the interface route from the master instance, and we're going to share it with the test routing instance. And then likewise, we're going to do the same thing in reverse. We're going to share the interface route from the test routing instance over into the master inet.0 routing table as well. And then third, we're going to take this a step further. We're going to attach, or we have attached another router here that's feeding in some OSPF routes. So those OSPF routes are coming into the test routing instance. And again, we're going to use the import rib statement, and we're going to share those routes from the test routing instance over into the master inet.0 routing table in the master instance. So let's take a look and see how it goes. For more information on rib groups, a couple of places you can look. First is a very good tech note called Understanding Rib Groups. It covers further use case examples of rib groups in general, and also some use case examples for route sharing as well. Configuration samples are included. It shows some of those variations I was describing about the different protocols and how the CLI applies in each case. So some good coverage there. You can see the URL to the PDF. Of course, it's also covered in technical documentation, just mainline technical documentation. The link there is a good place to start, and you can navigate from there to the links that are on that page. So that takes us to the end of this Learning Byte. Hope you enjoyed it and learned something. We will catch you next time. Bye for now. Okay, so let's start and look at a couple of things here. First of all, let's look at the interfaces. You can see the two GE interfaces as per the diagram. Let's also show the routing instances. And you can see a very stripped down routing instance here. There's really nothing to it other than an interface and then a protocols OSPF stanza that we will use a bit later. So the first thing we want to do here is share that interface route from the master routing instance with the test routing instance. So let's start by doing that. We're going to create a rib group first for this, done in the global routing options stanza. There we go. And it will be an import rib. And we need to define the source table, which is inet.0. That's the natural position for this route. And we're going to define the destination or target, and that's the test routing instance and its inet.0 table. And then we're going to point the interface routes from the master instance into this rib group. So that's done again in this case in the routing options stanza again. There's an item called interface routes, and we can point that into a rib group, and it's the one we just defined. So there we go. You can see there's the interface routes going into the rib group. It's an inet rib group, by the way. You're just seeing that if we don't specify inet or inet.6 for our the routes in question that we want to funnel into this rib group, it makes it inet by default, so IPv4. So we're pointing into the master to test routing instance, and it exists here as a rib group. The source is inet.0, destination is test.inet.0. Just before we commit that, let's look at the routing table. There we go. So you can see there's our interface information and the routing information for it. The 10 addresses in the inet.0 table. Also, since we're here, there's the addressing or the interface information for the interface that's in the test routing instance. And also there's the 55 and 66 OSPF routes. We'll see those again later. So let's commit this and see what happens. We want to be sharing those 10 addressing in 10 addressing information for the interface over to the test routing instance, and that's exactly what's happened. So that looks good. So as the next step here, let's do the reverse. Let's share the routing information for the interface route in the test routing instance, the 192.168 information, and try and share that up to inet.0. So it's going to look very similar here. We're going to start by generating, or creating rather, a rib group. Test to master, import rib, and in this case, the source routing table, or the natural routing table for this route is the test.inet.0 table, and the target or destination is going to be inet.0. Now, to point the appropriate interface route into this rib group, we need to go into the routing instance and go into the routing options stanza there. And there's the interface routes statement that we want. And let's point that to the rib group that we just created. And there we go. So let's just look at that real quick. Here it is. And again, this is why we spent some time back in the earlier slides talking about the importance of knowing the natural default source location of these routes when you want to share them. So we're defining the interface route that's part of the test routing interface, or routing instance rather, pointing that to the rib group called test to master. And when we do the show routing options, there it is, and it's looking good. Once again, let's do a quick look at the route table here. So the goal this time is to share these 192.168 routes, that routing interface information, up into inet.0, and let's see what happens. That looks good. There's our 192.168 source information, and there it is, shared into the inet.0 table. So let's go to the next step here and share the OSPF information from the test routing instance. We're receiving some routes there, those 55 and 66 routes. Let's share those also up to the inet.0 table. So again, same kind of thing here. We're going to create our rib group. Import rib. The source or natural default table is test.inet.0, and the target or destination is inet.0. So that looks pretty good. There it is right there. And as we keep going, those routes are received in the test routing instance, so we need to go into that routing instance, go to the OSPF stanza that was configured there, and add the rib group statement to point those incoming routes up into the rib group to be distributed. And that is OSPF to master. And so let's check things out. That's looking pretty good. So once again, let's look at our routing table. And it's these 55 and 66 routes that we want to keep an eye on. Let's commit and see how it goes. And there we go. The 55 and 66 routes are indeed shared up to the inet.0 table. So as a last step here, let's try some filtering. If you recall, there's the import rib statement, but you can also qualify or control or restrict what you actually share through that statement using the related statement called import policy. Now, the first thing we need is a policy to help us here, and I did create one in advance. You can see the policy statement called import rib filter, and it matches on the route filter the 66 route, in fact, the OSPF route that is the 66 route, and it's going to reject that. So if we go to our rib groups here, here's the item in question. There's the import rib statement. We want to add that qualifier, or that policy statement that restricts what we actually share. So let's add that in here. And I'll just pause here. You'll see the two options. There's import rib, and we've used that. But we're going to use the import policy statement, and we are going to reference that policy statement up above there and apply it. Here we go. Got our import rib. We've got our import policy. Again, before we commit this, let's just have a quick look at our routing table. So what we are seeing is the two OSPF routes, 55 and 66, successfully being shared currently up into the inet.0 table. And once we commit this, what we should see is it restricting the sharing of the 66 route? And sure enough, with that in place and committed, we now only see the remaining route, the 55 route, actually being shared. So that takes us to the end of the demo, and that's some options for how to use the rib groups for route sharing on a Junos device.
Visit the Juniper Education Services website to learn more about courses. View our full range of classroom, online, and e-learning courses. Learning paths, industry segment and technology-specific training paths. Juniper Network's certification program, the ultimate demonstration of your competence. And the training community, from forums to social media. Join the discussion.